Hello everyone, today we are going to create that seamless looped particle movement or particle system in geometry nodes. We will be able to control the size of our particle system. We can switch between some standard particle and some custom particles that you can create on your own. We will be able to control the particle speed. We will be able to control, of course, the density of our particle system and some other cool things. So if you want to know how to create that, just watch that video. So as usual, we will start with our default cube as particle container activated and clicked on geometry nodes and make a new geometry nodes setup. We disconnect the output from the input and we will create an icosphere. The icosphere will be our particle container. We make it maybe 2 meters and give it some subdivisions, 3, so that we can see some particles on it. And now we need a distribute points on faces node, and of course an instance on points node. And for the particle we will also take an icosphere, but the particle of course has to be way smaller, something like that, and we need only one subdivision. You can adjust that later on. Now we have a very small particle, maybe 0.5, something like that. Now we want to give it some random value. Therefore we need a random value node and plug in the float into the scale, minimum very small, maximum like this. We adjust that later. And also we have only some points now. We want later some random rotation. Maybe if we plug in some blood cells like you have seen in the intro scene. So also plug in the rotation and type in 0 and tau. I think tau gives you the maximum of rotation that's possible. Now it's time to give the particle some random noise movement, and therefore we are going to add an set position node, and we are going to need a random value node, which we set to vector. And when we plug that into the offset, our particles got distorted. Now the problem is, if we now put some noise texture over it, the noise will deform all 3 axes, and the random motion will not be as randomness as if we control each single axis. So therefore we have to make 3 different setups for each axis and give each axis a different noise texture, so we have a real random movement. Now to do that we need an combine X, Y, Z node, and now we start with the X channel. Put the first one, the X channel, to 10 maybe, and the other to 0. And now we got only some movement in our x-axis. Now it's got a little bit out of center. To make it center again, add a vector math node, set to subtract, and move it back in the x-axis so that it's almost centered. It doesn't have to be perfect, something like that maybe. And now we have to do the same, just copy and paste for the Y channel and the Z channel. So we can first copy our Z position node, and now we can copy all the three values, all the three nodes, I mean. Plug that, no, first of all, x-axis to 0 and y-axis to 10. Plug that to y, the vector into the offset, and now we have to control the x-axis, something like that. And again, last but not least, our Z channel. Copy again the Z position node and copy our three nodes. So just to make it clear again, we could use only one of these expressions to scatter our objects if you want to make a not animated image. But if you want to animate it and have some additional random noise to each axis and each particle, I realized that we have to make it with all three axes. So plug that into the offset, and now 0 to Y, 10 to Z, plug that into Z, and now 1.7 to the Z channel, and we should now have a cool distribution of our particles. So now it's time to make some animated noise. Therefore, we will start with a noise texture. Noise texture. We will set this to 4D because we want to animate it. The detail we can set to 0, the roughness we can set to 0, and with the distortion channel you can later on play around. It has some effect on your particles. We will need an RGB curve node. No, sorry. RGB curves node that will give some additional randomness. Now plug the factor into the other factor input. And how do we get now our noise into our Z position node? Therefore, we have to plug a multiply node between the combined XYZ and the subtract math node. Vector math node right here in between. We set this to multiply and now plug in our RGB curves. We can make some distortion. And as you can see, our particles start to move randomly, only at one axis at the moment, but we will change that later. So now we have to make some looped noise. We can achieve that with a vector rotate node. For the vector rotate node, we need to know the position of each particle. That we will do with a position node. Plug the position node into the vector and the vector output into our animation control. And now you can animate with the angle down here the particles in a looped animation. You have to imagine that vector rotate as some kind of circle going around, and each time the circle comes to its 360 degree point, the whole animation starts right at the beginning. So we can leave that at 10. With the center, you can imagine that as the center point of that imaginative circle, and you can play with these values. The animation will change slightly. So now we can plug that into, yes, right now we have it in our X channel. Maybe we make a frame around it to have better control and keep things organized. Let's name it noise X. Now just copy that whole expression, and now we need again a multiply node on the y-axis. Plug that into the y-axis and rename that in noise y. Copy that whole thing again and plug that into, no, sorry, we first need a multiply node. And now plug that into our multiply z node. So now we have control about all three axes. If that's the right word, axes. Now we can control it. For that we only have to move the angles. Later on you can make a link to your group input with all these values to control it in your modifier panel. But for the sake of this tutorial, I will only create a value node, which I plug in here, and plug in here. Damn it. Here. So now we can control our particle movement. It's very, very fast. We can change that by adding another vector math node between the vector rotate and the noise texture. Vector math node sets this to divide. Where's our divide? Divide, there. And when you set the number higher, I will just do that for all three axes. And again on the z-axis. Okay, that's a little bit messed up right now, but you know what I mean. Now, if I animate this, we have some random noise. The problem is that all three imaginative circles now move at the same time. To get it really random movement, we have to let the circle start at different points. So therefore we will need a math node. The first one we can leave at 0. The second one we add 100 degrees, and the third one we add 200 degrees. Now if I play the timeline, we already can see there is some random movement. But that's not enough. We can modify the scale of each axis texture, maybe something like that, and we can also modify our noise, our RGB curves. I think the important one is the last one. That. Maybe we can give some random distortion to it. And now we can see we have some pretty nice particles going around. Now we can still add some more noise movement. We can add a fourth Z position node. And the fourth Z position node will affect the whole particle setup, not only one axis. And therefore we can just copy that whole expression here. This, or maybe the whole container, copy and paste. Just move it to our fourth Z position node and just plug it right in here. And I will make a connection from here to that angle and add another math node, which I add to maybe 270. And now we should have some pretty nice random movement of our particles. Yes, there it is. Nice, smooth, random, looped animation. Now you can change your density with that value. You can change the all over size with the radius of your sphere. If you make it too big, you will realize that inside your sphere there are no particles. That's because your scattering is too low, and you can change this by maybe adding another value and plug that right into each random value with a combine X, Y, Z node. First one we will plug into the X channel and plug it right here. The second one we will plug into the Y channel and plug that into our Y channel, and the last one we will plug into our Z channel and plug that in our Z random value. Now you can have perfect control about the scattering of your particles. So now everything seems to be scattered and there is no empty room. And again, if I play the values, we have a pretty nice random movement. So how to animate that in a loop? Maybe if you have never done that before, I will show you. We have to go to the timeline. Now go to the first frame, set your axis to set your angle to 0, insert a keyframe, and now go to your last keyframe +1 and enter 360 degree and make a new keyframe. That's why, because the last frame and the first frame are exactly the same. So in that case, the animation will jump from the last frame right over to the first frame, and there will be a seamless loop and no frame between it. So if you want to plug in some custom particles, I've just prepared something. I've prepared here my my collection with my blood, my blood particle. Beware of if you plug in a collection, you have to activate separate children and reset children and activate pick instance. And if you plug in the blood right now, it's a little bit too small, but of course you can scale it up, and there you can switch easily between your own particles and some preset particles. Hope you enjoyed the tutorial and everything worked out for you. So if you have any further questions, don't hesitate to write into the comments. You can download the whole project on my Gumroad account if you want to. So see you on my next tutorial.